Okay, welcome today. Let's hope that this all works. I had to re-enter YouTube and start a new stream because I was bumped off at the very beginning. So whether you're watching this live or you'll watch it later, I'm hoping that things are word properly today. So we ended off yesterday, or 2 days ago. Yesterday was a work period. I ended up yesterday talking about all the special types of parallelograms. So a parallelogram is sides that are equal to each other and opposite sides that are parallel to each other. The special parallelograms we studied were the square and the rectangle, and then the rhombus. And you can look back at the notes that I posted. Even if the video is a little hard to watch, I am trying to figure out how to improve the quality of the videos I'm recording. So I'm trying a few different tricks today. So today, the parallelogram we're going to study, or pardon me, it's not a parallelogram. The first four-sided shape that we're going to study is the kite. So just to note, because we've been talking about parallelograms, this is not a parallelogram. Okay, this is a four-sided shape, of course, and there are some interesting qualities to it. It's called a kite because the shape resembles the kites that you see people flying in the air in parks and things. Hi, Cynthia. Yeah, I had to restart the stream, so nice to see you, or to see that you're with me. It has some equalities, right? These two sides are equal. So not the opposite sides, but these two sides are equal. These two sides are equal. There are two diagonals, diagonal number 1, diagonal number 2, and they meet at 90-degree corners. So just using the vocabulary that we've learned in the last couple of days, that's something to note. Are any sides congruent? Yes, the two sides right next to each other are congruent, okay? So I'm going to put down note the two sides next to each other. Sorry, I already made a mistake, right? Next to each other, consecutive sides. To introduce that word. So the side that follows the other, so side 1, side 2, if the two sides right next to each other are congruent, we say consecutive sides are congruent in pairs, right? These two are congruent and these two are congruent, but they're not all equally to each other. These two have 2 hash marks. That means they're equal to each other. These two have 3 hash marks. Those two are equal to each other. Okay. All right. Are any sides parallel? Well, just visually looking at it, it doesn't look like they're parallel, right? So visually that doesn't look like, and also there are no little arrows given. So if there are no little arrows given, then we say that no, the sides are not parallel. Hence, it's not a parallelogram, right? Oh, yeah, Cynthia, question? Okay, consecutive means right beside one another. So the sides next to each other. So these two sides are consecutive. Okay, and these two sides are consecutive. I know these two are consecutive as well, but I'm saying that they're consecutive in pairs, consecutive sides. Okay, right next to each other. Are any sides perpendicular? Well, perpendicular means one side meeting the other side, right? I don't see any box here, so these two aren't perpendicular. And these two sides meeting, there's no box here, so no. Are any sides perpendicular to each other? No. Are the diagonals congruent? Well, let's see. This diagonal is cut into 2 equal parts. This diagonal is not, so this side would be longer than this side. So are the diagonals themselves congruent? No. The diagonals are not equal, which is congruent. Are the diagonals perpendicular? Yes. They meet at 90-degree angles. And I know that because they meet at this, at a box. Do the diagonals bisect each other? No. This diagonal is bisected, but this diagonal is not equal parts. One diagonal is bisected by the other. But not both of them. And are there any angles of equal size? Well, we already know that the interior angles are equal because they're all 90 degrees. But the angles in the corners, we can see that there's these two angles are equal, and these two angles are equal. So we would say yes. I guess you would say opposite angles, the angles opposite to each other. And by opposite, we mean across from each other. It's hard to say. These two for sure are equal, so then these two are equal. Maybe I could do that as well. I'm going to put these two are equal. And if these two are equal, I'm running out of the number of hash marks. Then here, I'm going to do hash mark, hash mark. These two are equal, and then these two would be equal. It's a little hard to. It's easier to see, I think, than what I said verbally, but you can see all that congruous, they're placed side by side. These two triangles are equal to each other. So just keep that in mind, and that might help you with the sides and the angles. I see there's 2 people, and Cynthia, you're on live stream. You're saying the video is cutting in and out. Can you tell me what the quality of the picture looks like? If you could just let me know if it's clear for you at some point, that would be helpful to me. Okay, let's try this next one. Trapezoid. So this is called an isosceles triangle, or isosceles trapezoid. Remember, we had an isosceles triangle as well. An isosceles triangle had two sides that were equal. So it stands to reason that an isosceles trapezoid would have two sides that are equal. So let's see what this trapezoid is telling me. These two sides are equal. These two angles are equal. These two sides are parallel. Okay, it's very blurry. Okay, I'm going to try something. Cynthia, let me know. Okay. That's what seems to be happening. It's clear and then it gets blurry. Let me know if that cleared anything up. And if it becomes clear, like when you notice that it becomes cleary, if you could, or blurry, if you could let me know. So are there any sides that are congruent? Okay. So the two sides, I'm just going to put side A and side B maybe. Are any sides parallel? Okay, I'm going to say C and D. And that's what the little arrowheads mean, right? They mean they're parallel. Are any sides perpendicular? Okay, there are no, oh, okay, I'm gonna have to clear something up. I'm really trying, guys. I tried to do something to make this a little clearer. I think I'm gonna try to get connect to my computer in a different way to see if that clears things up. I'll post the notes online though, so hopefully that's good for you too. Are any sides perpendicular? No. There are no 90-degree angles. Are the diagonals congruent? Well, let's see. If I connected this side to this side and this side look like, right? And because I can see that there's two identical triangles that are formed, the triangles would be congruent. Yes. The same length. Okay. Okay. So let me try this. Are the diagonals perpendicular? It doesn't look like it how I've drawn it, but, and that is true, no. They don't meet at 90-degree corners. Do the diagonals bisect each other? Well, that means do they cut each other in two equally? And even with my kind of, okay, good. I'll just keep, you know what? I'm going to keep adjusting it because I've had to do that about 5 times. So I'll just keep trying to adjust it. Thanks. Okay. Do they bisect each other? No, they don't cut each other in half. Are any angles of equal size? Well, these two base angles, remember, and it's the same thing as isosceles triangle. If these two sides are equal, their base angles are equal. And they were recorded there too. The base angles are equal. Now, if the base angles are equal and a four-sided shape, the corners equal 360, so these two, if you flipped it upside down, these would be the base angles and they would be equal too, right? They would have to be equal. They would be just flipped over the other way. Then the next, so a trapezoid is just another type of four-sided shape. This is actually the shape of the student desks that we have in a lot of the classrooms at Adult Ed. So a trapezoid is just a four-sided shape with only one side parallel, one pair of opposite sides parallel, okay? Let's try to look at the last shape we're going to study in the four-sided family. It's a right trapezoid, and the reason it's a right trapezoid is because it has a right angle. That means one of its corners is 90 degrees. So it's a trapezoid because it only has one pair of opposite sides that are parallel. These two sides aren't parallel. You can see if this line was extended a long ways up and this side was extended, they would end up meeting. So are any of the sides congruent? No. No sides are equal. Are any sides parallel? Yes. Okay, these two sides, I'll just kind of call them A and B. Sides A and B are any sides perpendicular? Yeah, one pair of sides is, right? If I call this side C, yes. Are the diagonals congruent? So the diagonals would look like this, right? And I can see that there's no way. This diagonal would be a lot longer than this one, right? No. Are the diagonals perpendicular? They don't meet at 90 degrees, so no. Do the diagonals bisect each other? No. It's because one of the sides is kind of slanting outwards. This looks like the top diagonals are much shorter than the bottom sections of the diagonals. Are there any angles of equal size? Well, we've got two. If this is 90 degrees, this would have to be 90 degrees too, right? Because these two sides would be parallel. So two, okay, one pair. One pair of consecutive angles are both 90 degrees. So this angle and this angle. And those would be the only two that would be, and I can see this is an obtuse angle greater than 90 degrees. This is not obtuse, it's less than 90. So these two would not be equal to each other and they wouldn't be 90 degrees. Okay. Cynthia, can I ask you if it's clear still, if the video is clear or if it's blurring again? We've got page 5. And page 5 is in a regular class, if it's just regular, you would, or we would encourage you to copy this chart for the final exam. It summarizes all the four-sided shapes we talked about. Okay, it's a bit blocky. Okay, I'm going to try. So in this, for this semester, you know that you'll always have your notes and there's no final exam. So this would just be a really good chart to refer to because it's summarized. Okay. Okay, let's see. You can see it summarizes all the shapes, right? We've got all these are, remember, these are all types of parallelograms. Parallelogram. Okay, this is just the regular parallelogram, and these are all special types of parallelogram. But the whole family is the family of four-sided shapes, quadrilaterals. So let's take a look at example 1. Identify the statement that best describes the property of a rectangle. Okay, well, we've got our notes up here as well. Oops, sorry. So the choices I have, so I'm going to look for round rectangle. Diagonals of a rectangle are congruent. Let's see, rectangle, diagonals, equal length, yes. So that's true. A rectangle has only one pair of parallel sides. Okay, a rectangle has two pairs. This is false. It has two pairs of parallel sides. The diagonals of a rectangle bisect the interior angles. Okay. Rectangle, the diagonals bisect each other. The diagonals of a rectangle meet at right angles. Let's go back to the rectangle because I don't think all the info's here. So if I look back at let's just look back at this rectangle. Okay. So the diagonals for sure bisect each other, but the interior angles themselves are all different sizes. You can see that these two angles are equal to each other, right? These two angles are equal to each other. So opposite angles are equal, but they're not all the same. Okay, so that's something that we have to, sorry. Oh, I don't know what to do, Cynthia. Okay, I'm going to try and auto or readjust again. Okay, let's see. And this is false. And this is false. So A would be the answer, right? True statement is A. Right, let's try one more. The following shape is a parallelogram. State the measure of angle A. Well, remember, one of our rules is, or that we learned, the very first thing we learned about triangles was that the three angles of a triangle equal 180. So if I know that, if I know in a parallelogram, the other thing we learned was that opposite angles are equal in size. So D and B are equal to each other. And then the four angles of any four-sided shape have to equal 360, right? So that would mean that 360, take away 115, take away 115, is going to give me the leftover for those two angles. Very similar to what we did with triangles, right? So that leaves me 130 degrees for these two angles. And I'm going to divide by 2, and I'm going to get 65 degrees, right? So this angle has to be 65. This angle as well, 65. So angle A must be 65 degrees. State the length of side A and the measure of angle B. Same procedure as I did up here, right? 360 take away 50, take away 50 equals 260. 2. So these guys must be 130 and 130. So angle B is 130 degrees. And length of side A, well, if it's a rhombus means all sides are equal. It's similar to a square in that respect. All sides are equal except a rhombus is tilted on its side. So side A also has to be 8 meters. Example 4. Justify why the following statement is false. If a quadrilateral has one pair of parallel sides and one pair of congruent sides, then the quadrilateral must be a parallelogram. So if a quadrilateral has one pair of parallel sides and one pair of congruent sides, be a parallelogram. Well, I can prove it's false. Let's see. What about this one? Okay, I can have one pair of congruent sides and one pair of parallel sides, but this is not a parallelogram, right? A trapezoid has one pair of congruent sides